4.3, trigonometric functions on the unit circle. So we did touch a little bit on this maybe preemptively in our 4.2 notes. So when we look at putting a triangle on the coordinate plane, and the triangle is going to be because we have this central angle theta, and then instead of making this ray like we did in the last section, we're actually just going to connect our triangle down to the x-axis. So the triangles are always connected to x. We never do this. We never take a ray and then connect over to y. So that is bad. We don't do it that way. So we always connect our triangle wherever that terminal ray is for our angle down to the x-axis. And then instead of the hypotenuse, we now have a radius side because this could be the radius of a unit circle. And our adjacent side would now be like x because it is horizontal. And I'm going to write horizontal because, well, I think that should be obvious. It might not always be. And then the vertical side is going to be like our y. Let's see, r is radius. And so that gives us a new way to look at these trig ratios for a triangle. So our sine of theta is now y over r. Cosine of theta is now x over r. Our tangent is y over x. And then we'll go through and do our reciprocal functions. And then I want to explain to you the way that I use to memorize these. So the way I can remember these is when I think of tangent, y over x would be like slope. Slope is tangent y over tangent x. So that's how I remember tangent. And with cosine and sine, I know that c comes before s in the alphabet and x comes before r. So that's kind of the way, x comes before y. And I know that they're both over that radius. So that's the way that I memorize those. So you might have a different way. It would be great if you guys could share that in class later, but that's kind of what I use. So here's our first example. We're going to let negative 4.3 be a point on the terminal side of an angle theta in standard position. Find the exact values. So exact means no calculator of the 6 trigonometric functions of theta. So I'm always going to start by drawing a coordinate plane. So here's my coordinate plane. It's kind of a crooked coordinate plane, but that's okay. Negative 4.3, so if I'm starting at my origin, negative 4 up 3 would be somewhere in here. So then this is the terminal ray. So this is my theta right here. And then when I drop this down to my x-axis, and that's a right angle, again, kind of crooked today, my angle now that I'm going to use inside my triangle, right, that's going to be my reference angle. So I can go ahead and label two sides. My x side, if these x, y coordinates here, that means my x side is negative 4. My y side is 3. So this point is negative 4, 3, but it's also giving me the sides on that triangle. And I have a 3, 4, 5 triple. So 5 is my longest side. It'll be my radius. And now that I have all of that drawn out, I can go through and I can go ahead and take my trig ratios, because that's really what those trigonometric functions are of an angle. They are a ratio of our sides. So my sine of theta, sine is y over r. So y over r is 3/5. Cosine theta is x over r. So c comes before s, x comes before y. So x over r is going to be a negative 4/5. My tangent is the one that I've been saying is like slope, y over x. So 3 over negative 4. I know it's really tempting to think that you can do these without memorizing the XYR, but the XYR is really important. Your life will be so much easier and your answers will be so much more correct if you can remember X, Y, and R. So now I'm just going to go through and do my reciprocals. Cosecant 5/3, secant of theta negative 5/4, and cotangent negative 4/3. So I used that triple. Always good to just write that down when we use it. I'm just trying to think about anything I might have left out here. All right, so for our next page, we are looking at some really unusual angles. And the reason that these are unusual is that they are going to fall on our X or our Y axis. So theta, for example, cosine of pi, for example. I got theta on the brain. Pi, we know all the way around our circle's 2 pi, and so pi is right over here to the line. So this would be that angle pi. So now what in the world do we do when we don't have anything I can build a triangle from, right? So what I want to do is I want to use the unit circle to find these answers. And the unit circle would just be a circle that has a radius equals 1. And so if I look at these as being points on my unit circle, then it's going to take care of a lot of these issues for me. I'm going to have an R and an ordered pair like this. If I make a point, I can already come up with an XY. So if I can make this into a point on my unit circle, I now have an X, a Y, and an R. So I'm going to go ahead and draw that circle in. It's not necessary. I really just need an ordered pair, but we're just learning this stuff. So we'll go ahead and draw a circle in. That is not a bad circle, considering how things are going this morning and how crooked this has been. For some reason, there we go. Now I've got it fixed. So at this point, if I am on that unit circle that has a radius of 1, that means I am 1 unit to the left and I am 0 units up. So this point would be at negative 1, 0. So that would mean that my x is equal to negative 1 and my y is equal to 0. And because I am on the unit circle, my radius is also equal to 1. So if I know my x, y, and r, now I can go ahead and find my cosine. Remember, cosine is going to be x over r. So my x side is negative 1, my r is 1. So cosine theta is negative 1 over 1, or just negative 1. All right, next one, 450. So first of all, 450 is way too big. We know that's bigger than 360. So I want to go ahead and subtract 360. And I get 90 degrees, pretty sure about that. So let's go through and draw that again. I'm going to draw the unit circle first. It'll be easier that way. And then here's my 90 degrees. We always want to label our angle. At the very minimum, what I'm looking for here is that you've labeled an angle and you have a point, like an ordered pair point at that angle on the terminal side, where the terminal side would be, and you have the XY ordered pair. That's the absolute minimum that you need to have for work on these. So if I'm on the unit circle, that means I didn't go right or left, so my X is going to be 0, and my Y was up 1 unit, so 0, 1. So again, that's my X and my Y, and my R is automatically 1. And so now I want to take the tangent of 450, and tangent is Y over X. Tangent's like slope. So tangent of 450 degrees. My Y is 1 and my X is 0. Uh-oh. So if I have 1 over 0, then I am undefined. And that will happen sometimes. So let's go ahead and try our last one. 7 pi over 2. So I know that that's going to be bigger than 2 pi. So 2 pi, let's do a little bit of scratch work here. So I know that 2 pi is equal to 4 pi over 2, and that's a full revolution. So I'm going to go ahead and subtract 4 pi over 2 to figure out what would be left, and that's going to be 3 pi over 2. So I know that 3 pi over 2 is like 270 degrees. So coordinate plane, unit circle, which I don't really have to draw, but I am just right now. 270 degrees would be all the way around to here. We're calling it 3 pi over 2. And here is our point on the unit circle. So let's go ahead and label that. My X is 0. My Y would be a negative 1. So that's my X and Y. So at the very minimum, I need this point. I need an ordered pair. I need your angle. That's the minimum. And my radius is always equal to 1 in the unit circle. So now I need to find the cotangent. Sometimes when I move the screen, it just snaps back up, and I have no idea why. So my cotangent is going to be, let's see, if tangent is y over x, this is going to be x over y. So that's going to be 0 over negative 1. And you wouldn't really need to show this. You could just say cotangent 7 pi over 2 equals 0. All right. So reference angle, I kind of talked about this a little bit before. It's the angle between the terminal side and the x-axis. So it's when you draw that triangle. So it's the angle in the triangle. So sometimes if you're like in quadrant 1, the reference angle and the angle you're drawing to begin with are actually the same, and then sometimes they're not. So we're going to sketch the angle and find the reference angle. So let's see, 150 and negative 150. So that means I would start and go clockwise, and this would be negative 90. Negative 180 would be to the line, so negative 150 would be somewhere over here. And so I'm going to draw this triangle. And so if this line is at a negative 150, but this is 180, and I want to figure out the difference, or negative 180, I guess, and I want to figure out the difference between those, 180 minus 150 would be 30 degrees. And so my reference angle is going to be 30 degrees. And then just to quickly label this triangle, so I'm going to say theta r equals 30 degrees. That's my reference angle. And then I think we should, though, just take this chance to label our triangle and get some good practice on that. Across from the 30 is the 1. The hypotenuse would be 2, or radius side is 2, and my other side is square root of 3. That one's across from the 60. So I can tell 1 is my smallest side, 30 degrees is my smallest angle. Those are always across from each other. And then I just want to think about signs. The square root of 3 should be negative because I'm going left on the x-axis. This one's going down. So negative square root of 3, negative 1, and 2. So 3 pi over 4. So I know that 1/4 of 180 degrees is 45 degrees. And so this 3 pi over 4, I'm thinking about how if I take this circle, I'm looking at just the top half here, and I divide it in half and I divide it into quarters, that this is like 3 of those quarters, okay? So that just tells me a little bit about, I'm thinking about fractions and how to draw this. So 3 pi over 4 would be right over here. And then all the way to the line, 180 degrees is just pi. And that would be the same thing as 4 pi over 4. So then we can see really easily what is between these two. So what's between 4 pi over 4 and 3 pi over 4? Just pi over 4. So that's going to be my reference angle. So theta r, this, I'm telling you, sometimes the screen snaps back up and I have no idea why. So my reference angle is pi over 4. So if we start in radians, we work with radians. If we start in degrees, we work in degrees. So it just depends on what you're given. And then I want to go ahead and label this one. So pi over 4, I know from my little scratch work already, is 45 degrees. So this is a 45, 45, 90 triangle. So it's 1, 1 square root of 2. And this one should be a negative 1. So again, we didn't have to label the triangle. I just think it's good practice. For 4, it says find the exact value. Whenever they say exact value, it means no calculator. We're going to have some kind of ratio. We've got special triangles or something going on here. So just really watch for that. So that means special triangles, no calculator. And so sine of 4 pi over 3. Well, let's think through with our fractions again. I know that 1/3 of 180 is 60. So this would be like 4 times 60. So if I think about this as 3 pi over 3 would be here, and then 4 pi over 3. So let's go ahead and label this. So this will be 4 pi over 3. So that means this line right here is at 4 pi over 3. That would be for this angle. And then this would be pi, or 180, which is 3 pi over 3. So then what's between those? And between them is pi over 3. And I know that that's going to be 60 degrees. So I'm just going to write that there as a reminder. So that means this other angle is the 30-degree angle. So across from the 30 is a 1. The hypotenuse would be a 2, or radius. And then my other side is square root of 3. And then I do need to add in negatives to reflect what's going on here. So it's a -1, a negative square root of 3, and a +2. And then I'm trying to find the sine. So my sine is my y over r. When I say sine, it also makes me, I can almost envision it spelled with a y. Remember when we did rise over run in algebra 1, and we'd spell the rise with a y to remind us it was y? Well, that's kind of another thing we could think of, another trick to remember that sine is y over r. So sine of 4 pi over 3 is going to be my y side over my r side. Y is negative square root of 3, and r is 2. So negative square root of 3 over 2. So next is tangent 150. I know you guys like working with degrees. They're easier. So 150 is going to be in quadrant 2. So remember, like, this angle line is at 150. This is 180. So between them, that angle for my triangle, my reference angle would be 30 degrees. So across from the 30 is a 1. Radius is 2. And then my across from the 60 is my square root of 3. And square root of 3 should be negative. I am going to erase these little, I'm trying to make clear to you how I'm coming up with that reference angle, but it looks really weird to have that little tail on the triangle. So I got to erase that. I just can't do it. This was a right triangle, and tangent is like slope. So slope would be change in y over change in x. Same thing for tangent. So my tangent of 150 degrees is going to be my y over x. So that's 1 over the negative square root of 3. And we would need to rationalize that. And so the tangent of 150 is going to be square root of 3 over 3, negative square root of 3 over 3. We can put the negative level at the fraction bar, the numerator, the denominator. I just always think it looks really weird to have it in just the denominator. So I either put it level or with the top. And now onto our last example. So this one, we're given one trig function, and now we want to find all of the others. So we're given the secant. So let's think about how secant is related to cosine, because we have that s goes with c thing. And our cosine is our x over r. So that means that this is going to be r and this is going to be x. And it says where sine of theta is greater than 0. So theta is y over r, but r is always 1 or greater than 0, right? So we can't have a negative r side. So what this is really saying is that my y is greater than 0. We want to find the exact values of the 5 trig functions. So the reason that they told me this stuff about sine being greater than 0, and this is what the secant is now I can see that the x is a positive 5 and y also needs to be positive. And so that means that we're going to be in quadrant 1. So I have x is positive and y is positive. And so that means I am in quadrant 1. So that's why they gave us all that information and why I kind of carefully dissected it. I can't just draw a triangle anywhere. So in triangle 1, in quadrant 1, I'm drawing a triangle. My theta is going to be right here. And so I know that I have my x side is 5 and my y side is square root of 29. And then I know that I could do Pythagorean theorem to get that third side. So remember, if we have a squared plus b squared equals c squared, and then I wanted to find one of the legs, it's going to be c squared minus b squared, and it'll be the square root of c squared minus b squared, because we're always rejecting that negative value. So this is just what I'm going to do. I'm just going to do that. I'm not going to worry about this whole Pythagorean theorem. So my hypotenuse is square root of 29. So I would do square root of 29 squared minus 5 squared. And this is all, we're going to take the square root. So 29 minus 25 is going to be 4. And the square root of 4 is just 2. So that's how I get that third side on my triangle. So I just did like a shortened kind of condensed form of the Pythagorean theorem. So now that I have x, y, and r, now I can go through and do all of my trig functions. So I'm just going to go ahead and write them all out. Sine theta, cosine theta, tangent theta, Probably should leave a little bit of room for rationalizing, and I have not, so let's take a look at this. So sine would be my y over r, so 2 over square root of 29. Sure enough, I got to rationalize, so I'll multiply by root 29 over root 29. I think I'm just going to erase these other two. As much as it kills me, it'll just be faster to have the room to write. So that means my sine is going to be 2 square roots of 29 over 29. And then I'm going to find my cosine. So cosine is 5x over the square root of 29. So 5 over the square root of 29. And when I rationalize that one, after doing the first one, you can kind of see it's going to be 5 square roots of 29 over 29. And then my tangent. So let's see, my y side was 2 and my x side is r, so 2/5. So I'm going to go ahead and do my cotangent right now because that's going to be super easy. And then I can scroll back up so I can see the triangle again. I think all the other ones are going to be faster though, right? Because we can look at reciprocals. And if we look at the beginning of our problem instead of our final answer, like I don't want to take 29 and flip that over 2 square roots of 29. When I flip this, I want to go back to here. So then that's going to equal square root of 29 over 2. And then I was given the secant, but I could also just look at this. It's almost easier to look at this and rewrite it than it is to scroll up. So that's going to equal the square root of 29 over 5. This is the last problem on our 4-3 notes.